Okay guys, good afternoon. Welcome to my presentation. Today we'll be talking on cloud computing and others I did. Now, what is cloud computing? Cloud computing can be simply defined as a model for delivering computing services like storage, server, databases, software, online, that is through the internet, without the need for looking for or going through the option of getting local servers. So now we have types of cloud. We have the public cloud, the private cloud, and the hybrid cloud. The public cloud, as you know, is hosted on public server. The private cloud is privately owned, while the hybrid cloud is a mixture of both public servers and private servers. Now, go to the next thing, Google Cloud Services. So I define cloud computing as providing computing services. So what are these Google Cloud Services? For cloud computing, we have compute services, we have storage services, we have artifact registry services, we have networking, analytics and big data, machine learning and AI, developer tools, identity and security, developer and operations, logging and monitoring services. Now, compute services, we have our compute engine, cloud run, cloud functions. Storage services, we have our Google Cloud Storage, Cloud SQL, Spanner, Firestore, all of them. So artifact registry services are just like a storage service to store your artifacts. That's what you use during developing your applications. So networking services are something like content delivery network, CDN, cake delivery network. Then we have Google DNS, then all those network services. Now, machine learning and AI services are something like Vertex AI, Vision API, and the rest of them. So, identity and security services are something like IAM, which is Identity Access Management, then Google Cloud Armor, then Cloud Identity. So, now cloud logging and monitoring services are Cloud Logging, Cloud Monitoring, Cloud Trace. So these are the services provided by Google Cloud. So now we'll go to the next one, core cloud concepts. What are these core cloud concepts? We have our serverless computing. So according to serverless computing, this tells us that Google Cloud is hosted without you worrying about server, without you worrying about infrastructure. So it is completely serverless. Now we have container scalability. Now container scalability means you can scale your number of containers, your number of virtual machines horizontally, vertically. You can scale the number of RAM, virtual RAM, and room. That's vertical scaling. Then you can scale the number of virtual machine instances. That's horizontal scaling. So now access control. So according to this, you can control who has access to your Google Cloud infrastructure. Now, benefits of cloud computing. The benefit of cloud computing includes cost efficiency, pay as you use, as you all know. Scalability and flexibility means you can easily scale your number of virtual machines up or down, and then it is flexible. You can change your data, you can update your data. Now, high availability means it is available to all users. It is worldwide, it is global. Unlike a local server or a private server, something that is built or owned by your own company will not have this feature of scalability or flexibility. The reason is because you have to pay for extra virtual machines that you don't need if there's a little traffic. When I mean traffic, I mean number of people using that your service at that particular time. So when there's a little traffic, the rest of your virtual machines, the rest of your resources are useless. But if you are using something like Google Cloud, that is cloud computing, you can be able to get the exact amount of compute resources you need. So that's scalability and flexibility. Now, cloud service models. Cloud service models include infrastructure as a service, that is IaaS. This provides virtual computing resources customization. So for infrastructure as a service, which cloud architectures do, also cloud developers, They can be able to customize the virtual machine. They can be able to customize the cloud web. They can customize a lot of things in infrastructure as a service. Now, platform as a service, which is specifically for cloud developers, what we can do here is we can build apps, applications. So that's platform as a service for developing applications. Then the last one, software as a service, is for users. It is where users can access or use applications already built on the Google Cloud. Now, ways to interact with Google Cloud. How can we use Google Cloud? We have Google Cloud Console. Google Cloud Console is a graphical user interface, GUI, whereby we developers or architectures or cloud engineers can be able to tweak any settings, customize any settings we desire on Google Cloud. Now we have Cloud SDK, Software Development Kit. So Cloud SDK is what we use as a programming to program our resources, to program our usage of cloud. So Cloud SDK or Cloud Shell is an alternative to Google Cloud Console. So instead of you physically seeing the settings you are setting, you can use Cloud SDK and Cloud Shell to program it. So there's also programming in Cloud. Now, Cloud API. Cloud API, Application Programming Interface, is a set of services that provides communication or interaction between resources, between servers. So between applications, sorry. So that's what API does. An example of this API are, we have compute storage API, networking API, machine learning API, compute API. We have a lot of API. So now, Cloud Client Libraries. Cloud Client Libraries enables us to use Cloud Shell, Cloud SDK on Python. Like, you can use it with Python, you can use it with Java, we can use it on VS Code, we can use it on every what they call it, languages, programming languages. That's the benefit of Cloud Client Libraries. Once installed in something like VS Code, you can be able to code, develop a cloud right on your computer locally with Cloud Client Libraries. So Google Cloud CLI, Google Cloud Command Line Interface, is another way of interacting with Google Cloud. Instead of visually setting up settings on your cloud console, you can use Google Cloud Command Line Interface to program the settings. Now, who are cloud developers? Also, what do we do? Now, a cloud developer or a software developer is a person that specializes in building, deploying, and maintaining applications or services in the Google Cloud. So that's just basically what we do. So what actually we do is we leverage the platform services on Google Cloud to create and manage our applications. Now, geographic locations where Google Cloud servers exist. So, worldwide map, I've presented this before. These are where Google Cloud servers exist. We have like 5 continents. So, except Africa. Africa does not have a Google Cloud server recently. Now, these are regions. We call them regions. What you see on the board. So, we have North America, which is US region. South America, we have Europe, we have Asia, we have Australia. Now, under them we have zones. So, zones are located under regions. So, regions can be subdivided into zones. So, we have these zones for redundancy, so that we can be able to have our cloud servers more stable, their performance will be okay, in case a region fails. So, we have zones. So, a region is a geographical area that contains multiple zones. Now, a zone is a deployment area within a region where we deploy our virtual machines. It's called zones. We can deploy it across multiple zones in a region or across multiple zones in multiple regions. So, now, how Google secures its cloud infrastructure. Google actually has security layer in this cloud stuff. That means it is very hard for anybody to easily hack it, unlike other programming systems. So now, Google has what we call hardware infrastructure layer. First of all, they secure their hardware, they secure their server, they secure their servers, they secure even their buildings, infrastructure. They put people securities there. So we call them hardware infrastructure layer. Then we have service deployment layer. How they deploy their services. That medium through which they deploy it, it has to be secured. So they do this by encrypting their communication. So if you have a Google Cloud worker and another Google, working in their station, for example, so they have to use encryption to be able to log in to access their system. So they cannot easily hack if they have a bad mindset. Now, user identity layer. User identity layer is something that can control the number of workers in that cloud station. For example, if a worker has been fired or just decided to leave, they can use user identity layer to exclude him from having access completely from their cloud station. User identity layer can also be able to manage the users, update their policies, that is their permissions, their rules. So we have storage service layer. So they are, even the storages that they offer us, they also implement security in them through encryption also. Now we have internet communication layer, that's the user's end. So at the user's end, they also implement security, something like online sign up when you want to sign up to Google Docs or all these things. So it's internet communication layer. And that internet communication layer is subdivided into Google front end, GFP, and denial of service. Now, we have operational security layer. That's the last form of security Google Cloud provides. Now, going on to the next. Hierarchy in Google Cloud Workspace. I've said this before, Google Cloud has a particular hierarchy in its workspace. So a workspace is a IDE, integrated development environment, where we can be able to run our virtual machines separate from the normal cloud project cloud now. So now in this workspace, if your organization decides to host a web application, so there will be an organization, they will be on the level of organization node. That will be their hierarchy. Now under it, you as a worker or you as somebody that is using this thing, that is configuring it, you'll be on project level. So on this project level, you can see that you don't have the permissions as organization would have. All of, like, this is the hierarchy of the Google Cloud Workspace. We have organization node to folder, to project, to resources. Now resources is just all those things like compute engine, virtual machines, all those things you see on your Google Cloud Console. So those are resources. Now, IAM function on Google Cloud. IAM stands for Identity Access Management. It's a service that provides access control. So what IAM does basically is IAM grants roles and permission to users, to service accounts, to user accounts, to project accounts, to workspace accounts, any accounts. So IAM grants permissions and rules to them. So IAM is divided, there are three types of IAM. We have basic IAM rule, we have predefined IAM, and we have custom IAM. Basic is because it's more broad, but custom is more specific. For example, in basic, we have viewer, editor, billing, we have owner. All those rules are basic. But when we want to give specific set of predefined rules, we go down towards predefined IAM rules. When even we want to customize it further, we go down towards custom IAM rules. So now the next one, the next one is service account. Why service account? So what is a service account? especially, a service account is a type of Google account that belongs to an application or service, not a person. For a person, you can have a user account, you can have a workspace account. But for an application, for something like API, you can have a service account. This is because for you to be able to manage or access any resource, your application to be able to use any API, that is Google feature, or access any Google services, you need that application must have a particular account that authenticates it. So without a service account, an application cannot be authenticated to be able to manage or use a service on Google. Now, so types of service accounts, we have user managed service accounts. These are service accounts managed by users. Default service accounts. These are service accounts automatically created by Google Cloud. Then we have Google managed service accounts managed by Google, that is used internally by Google services. We have use cases for them also. For user managed service accounts, we have virtual machines, Cloud Run, Kubernetes. For default service accounts, we have App Engine, Cloud Functions, that's Cloud Run function. Then for now on to the next one, we have need for cloud identity. So like I said before, cloud identity is used to manage the users or workers on cloud station. It can control their access. So now, cloud identity is basically Google's identity access management solutions that help organizations secure and manage user identity, and so on and so forth. So without cloud identity, we cannot be able to establish this security on our Google project. So we need it, so Google Cloud needs it for security purposes. Now, let's compare cloud identity and IAM. Look at this slide. Cloud identity, the purpose of it is for user identity and access management, as I said before. But IAM is for role-based access. That is, cloud identity gives user identity and access management, while IAM gives role control over your Google Cloud resources. Now, the manages now, what cloud identity manages are, it manages users, it manages devices, and it does what we call authentication. Now, Google IAM manages just permissions for Google Cloud services. Now, used for what? Cloud identity is used for employees, contractors, and software as a service access. While Google IAM is used for cloud services, API, and workloads. So in theory, cloud identity controls user access, user identity, and provides them access for them. While Google IAM gives what? Roles and permission to use certain services, to use API and workloads. Google Cloud Console. Now, what is Google Cloud Console? This is a web-based graphical user interface that allows us to manage, monitor, and configure Google Cloud services and resources. So, I told you that there are I mentioned 5 before, different ways of utilizing Google Cloud. I told you we have Google Cloud Console, we have Google Cloud SDK, or Google Cloud Shell, we have Google Cloud App. Now, Google Cloud Console is a way of utilizing Google Cloud because it's just like a web link. We can click it. If we log into it, we create an account, we can be able to manage, monitor, and configure our Google Cloud services. So, Cloud SDK. So Cloud SDK stands for Software Development Kit. Is command line tools, is a set of command line tools that allows you to interact with Google Cloud. So in this case now, we do what they call programming. We program code that is commands for us to be able to use Google Cloud. Example, we have Google Cloud Shell. Google Cloud API. Google Cloud API are set of REST API that allows applications to interact and manage Google Cloud services programmatically. So Google Cloud provides this API for applications that we develop to be able to communicate between themselves and the users, and for us to also manage them. And I mentioned those API. I mentioned storage API, I mentioned compute API, I mentioned machine learning API, I mentioned networking API. So those are the several categories of API that we have on Google Cloud. Now, Google Cloud app is general. So it's just your mobile app. So under it we have both Google App Engine and we have Google Cloud Application. So Google App Engine is a fully managed platform for building and running web applications like us web developers. Where do we build and run our web applications? We have Cloud Run, we have Kubernetes, we have Google Kubernetes Engine. Google App Engine is the general name for it, and it is a platform as a service which we use to run and manage our applications. Cloud App is just a general term. It refers to any application running on Google Cloud. Any application you build on Google Cloud is just a Google Cloud application. Now, let's compare those certain stuff I mentioned, which we have Cloud API, Cloud SDK, Google Cloud Console, and Google Cloud App. So, this is just a broad diagram that compares them. For features of Google Cloud API. Google Cloud API, the features are we have what we call RESTful API. Now, Google Cloud API, I told you before that it allows you to, or allows your applications and services to communicate. So, for features of Google Cloud SDK, it's just Cloud Shell. So, because and CLI, what I call CLI is command line interface. Because in Cloud SDK, we call program. So by programming, we can be able to control our Google Cloud. Now for Google Cloud Console, it is just the Google Cloud Console app, because we have a graphical user interface whereby we can select certain settings to manage our Google Cloud. Then Google Cloud app is just the general term. Then we have how to access. How does Google Cloud API access? The access through HTTP request. For Google Cloud SDK, it is what called Terminal G Cloud CLI. For Google Cloud Console, that's how they access them. For Google Cloud app, you can have your Android or your iOS app. So for authentication, let's go down to authentication. For Google Cloud API, how do they authenticate? They authenticate through these keys and service accounts, which I mentioned earlier. Authentication is important because without authentication, your Cloud API will not allow any communication between your application and the Google Cloud services. So, for Cloud SDK, we have a special authentication for them. For Google Cloud Console, is your Google account that is the authentication provided, and also for Google Cloud app. Back to the next one. What's the VPC? VPC stands for Virtual Private Cloud. So VPC is a secure, individual, cloud hosted on a public cloud. So let me come again. It's a virtual network within Google Cloud that allows you to create and manage resources such as virtual machines and other services in a private, isolated environment. VPC has an IP address range for your resources, and this IP address is subdivided into what we call subnets. Compute engine and its features. Now, Google Cloud Compute Engine is very important and vital because it is where we actually run computing resources, computing services, such as where we create our virtual machines, where we deploy our applications, that is cloud run, and where we control them, manage them. So now, Google Cloud Compute Engine is an IaaS, that is Infrastructure as a Service. To create and manage virtual machines on Google Cloud. It provides scalable, flexible, and high-performance computing resources for a wide range of workloads. Key features of Compute Engine. What are the features of Compute Engine? We have virtual machines, VM. We have they are scalable, that is, they automatically scale. Now, we have persistent or ephemeral storage, something like that is temporary. We can have either a persistent or temporary storage. We have networking and security. Compute engines have networking and security, and we have automation and management. Compute engines have the ability to manage themselves and automate. Now we have preemptible and spot VMs. This is a special type of virtual machine. So there's key differences between preemptible and spot VMs. So preemptible VMs have less features. Their runtime is 24 hours. Now for spot VMs, they have more features. Their runtime is maximum. That's it's not set to 24 hours. But their pricing is the same. So unlike Compute Engine, we can use preemptible and spot virtual machines also because of their pricing. They have cheaper prices when you use them. Cloud load balancing. Now, what is cloud load balancing? This is a fully managed service that distributes incoming traffic across multiple back-end instances to ensure availability, reliability, and performance. So what does this mean? Whenever you are deploying or whenever your application is running for public, it is available for the public to use. So there can be certain instances when the traffic will be high and certain instances when the traffic will be low. So cloud load balancing actually smoothens this out. If you need to scale up your virtual machine, that's what cloud load balancing does. If you need to scale it down, cloud load balancing does it. So that's the meaning of load balancing. How we access Compute Engine instance. Now, there are various ways by which we can access this Compute Engine I've been talking about since. The first way, or the first method, is to use your Google Cloud Console. That's the graphical user interface. So when you go there, you go to Compute Engine, click it, then you click Create Instance. You choose your machine type, you choose your operating system, you choose your disk size. You configure your network, security, and startup scripts, and you create your Compute Engine. Then it will be deployed for you to use. Now, the second way to create a virtual machine or Compute Engine is using Google Cloud Command Line, CLI, that is Google Cloud Command Line. So in this method, you use Cloud SDK, Cloud Code, or Cloud Shell. You input this command and it automatically creates your compute engine for you, because everything we mentioned here is default inside this command. Now, the next one is using Terraform infrastructure as a code. Terraform is a setting cloud shell also that Google has provided for us to use for coding. So it's a bit complex also. You put in this code and you'll be able to generate your complete engine. Now we go to the most vital part of the cloud developer course, which is developing applications with Google Cloud. I will quickly go through this part. Now, whenever we are developing applications on Google Cloud, there are certain things cloud developer considers. The first thing we consider is global reach, because we want everybody to use our application. So our application must be responsive and accessible to users across the globe. Now, the next one is scalability and high availability. Anytime the users want to use our application, it must be available. It's not until we send our workers to go and be doing to be operating the server. It must be always available for our users, and it must be able to scale the number of resources it's using, so that we cannot pay for more resources that we don't need. Now, the next one is security. We must be able to secure our application and its underlying infrastructure, and also our updating. Now, these are the three things that we consider when building our applications on Google Cloud. So, having considered this, the first step we do to sort out this problem is our codes, we store them on what we call code repository. Code repository is a secure way for storing our codes. So we have what we call dependency management. We store our dependencies on external packages called code repository also. So the next one we call configuration settings. So we separate our configuration settings from our code. We store it as environment variables. In doing this, we're able to secure our codes, number one, and we're able to make it easily deployable. Like, we want to deploy our code when we want to run it, we can easily deploy it. Now, the next thing is consider implementing microservices. There's what we call microservices, and the opposite of it is monolithic services. Now, microservices is when we split the service of an application, we split it into fragments, so that we can easily manage those fragments, we can easily update them. But monolithic service is when you just have a complete stack of services, a complete stack of your code, just at once. So if you look at it, instead of implementing a monolithic application, consider implementing or refactoring, that is, changing your code of your application to a set of microservices. The reason is because microservices enable you to structure your application components in relation to your business boundaries. Make sure to evaluate the cost and benefits of doing so. In case we want to update our application, microservices is better, because if we have a bad update or a bad changes to the configuration of our application, if we use a monolithic application, that's all the whole application will run down. Like, it won't work, no user will be able to access it. But if we have something like microservice, if a particular part of our service is not functioning, the remaining part of the application can still function. So that is one of the advantages of using a microservice instead of monolithic. Now, perform asynchronous operations. When I mean asynchronous, I mean something that does not follow does not have patterns. So, as a Google Cloud developer, we must be able to perform back-end operations that are asynchronous, that happens both quickly and without any pattern, and even automatically, so that we can be able to manage the traffic that comes into our application from the front end. So remote operations can have unpredictable response time and can make your application seem slow. Keep the operations that happen in the user thread at minimum. Perform back-end operations asynchronously. Use event-driven processing where possible. When I mean event-driven, I mean something like PubSub, whereby something, an event causes a processing to occur. So now, design for loose coupling. As cloud developers, we ought to design our packages for loose coupling so that they are loosely coupled. So the routine is look at this. In the context of HTTP API payload, consumers of the HTTP APIs should bind loosely with the publishers of the API. The consumers are the front end, the publishers are the back end. So they should bind loosely. There should be something like event-driven processing, like I mentioned before. This will be able to enable our application run smoothly. Design for loose coupling. The next one is implement stateless components for scalability. When I mean stateless, it's something that do not share state. In other words, they don't store something internally, they store it externally. That's the meaning of share state. So when we implement stateless application, it enables our application to be easily scaled up or scaled down. So that's the benefit of we doing this as cloud developers. Now, next one is handle transient and long-lasting errors gracefully. When errors happen with our application, we handle it gracefully. What I mean by that is, if we retry, we implement what we call retry logic. So if there's an error in our application retries it until you reach a maximum retrying, until you retries it to a certain amount that it just terminates that part. So that is what we call handle long-lasting errors gracefully. So retry with exponential backup and implement a circuit breaker for our application so that we do not waste CPU resources. That's why we have to implement a circuit breaker. Now the next one is cake content. Now, as cloud developers, we need to get cache, C-A-C-H. So we need to cache content. So when by caching content, we can improve application performance and lower network latency. Now, if we cache content, we keep those contents closer to our users instead of their server downloading those information. So we cache it, stored closer to our users. So this will improve performance and also lower network latency. How do we cache contents? We use something we call CDN, Content Delivery Network. It's on your web application. Now, we are done with certain things developers must consider when developing applications. Now we move to storage options. Now, under developing our applications in Google Cloud, we also need to consider storage options. As we all know, our applications need to store certain data. Now, if you can read this, application, for example, a social image sharing site, has to store the images it's sharing. Now, it has to store user messages. It has to store transactional data. It even needs to store query that you collect. That's query, like when you want to check the performance of your application, you call it query. So, how do we store and gather all this data? So, let's move on. We have Google Cloud provides a full suite of storage service options. The first one we have is cloud storage. We have Firestore, we have Bigtable, Cloud SQL, AlloyDB, Spanner, and BigQuery. How we choose them is based on certain features like cost effectiveness, application workload, usage time, even time, whether your data is structured or unstructured, or the mode, whether it's multimodal, even global reach. That's certain things that makes us select a certain type of cloud storage option. Okay, now talking about cloud storage service options. The first one we have is cloud storage. Now, why we choose cloud storage is if we want to store unstructured data as objects with their metadata as well. So, cloud storage provides up to like 5 terabytes of storage for you to be able to store any data, and it is accessed through HTTP request. It is stored on what we call static websites. Examples of those data are images and videos. Now, the next one we have is Firestore. Firestore is a fully managed serverless NoSQL. Means it does not store structured data. It is scalable. It can host mobile and web applications because it easily updates. It has real-time updates and offline features. So it is as well fast enough. It can be able to process transactions, store transactions as well. And that's it. The next one we have is Bigtable. It is also a high performance NoSQL database. Now, Bigtable store large amounts of unstructured data as well. Now, it is used for both operational and analytical applications. That's something like banking services. Banking services here. It can store terabytes to petabytes of data. And sparsely populated, it has a sparsely populated table. Next one is Cloud SQL. This is a relational database service. It stores structured data. Now, examples of those Cloud SQL we have are MySQL, PostgreSQL, and SQL Server. It is secured. That's the feature of it. It does what we call online transaction processing workload. That means it has to be secured. Cloud SQL is secured. It's hosted on Google Cloud. Now the next one we have is Spanner. Spanner is highly available. It can easily scale horizontally. That is, it can scale to increase the number of resources. It is consistent in requirements. It can store large data, relational data, because it's a relational database storage also, like Cloud SQL. But unlike Cloud SQL, Spanner provides, it can easily scale horizontally. That means it can increase the number of resources it's using and it can easily update. But Cloud SQL scales vertically, means it can increase the number of RAM, CPU, and all those certain things. Now, BigQuery. BigQuery is not really only for storage. It does other things like querying, storing queries, and so on and so forth. It can store up to petabytes of data. It has fast response times. It is used for reporting with business intelligence, and also does that online and analytical processing. So this brings me to the end of cloud storage options. I'm also done with the course as well.
I am here again. All right, so that was a very wonderful presentation. presentation, very awesome presentation by Mr. Benjamin. Mr. Benjamin's track is on cloud development, which should not be confused with cloud architecting. And he's done a very wonderful job with this presentation. So right now, I'd like to open the ground for questions from the audience. I'm seeing a few hands up. Let's start with Jemima, what's...
Cloud development is also software development. What's the difference with software engineering?
Yeah. So, unlike software development, cloud application development, we host our application on Google Cloud.
I said software engineering.
Okay, the difference between software engineering and cloud
I said
development.
software development. When I was defining cloud developer, I said it's a software developer, so that's what she's asking.
Okay.
So I'm clarifying the differences.
Alright.
So like software developer, develops any application. But cloud developer develops application and hosts it on websites. Something like Gmail now, Google Docs, all OneDrive, all those things. So that's what cloud developers do. They also create that workspace. They manage the workspace as well as developing applications. They have to manage the workspace. They have to run the virtual machines and all of those sorts. So their own world of field is different from software developers. But they also learn the same programming that software developers learn.
And you're talking about, I don't know if it's different, or the features of cloud, I think cloud computing and high-end. Yeah, so there was something like MFA and MSO. What does it mean? MFA and MSO. I said on the slide. What does it mean?
Under
Just
features
go
of
to that
cloud.
area. Yeah, features of clouding and high-end.
Multi-factor authentication.
Okay,
Oh.
that's me.
Okay.
And MSO.
Okay, that's like a security, multi-factor authentication. I believe you'd have seen it in cloud security infrastructure. Yeah, because for users, for something like user identity now, we have what we call OAuth. It's also authentication too. So all these authentications are to prevent hacking or access by any system.
Okay.
Strange.
Then you mentioned something about you guys managing what do you call it? Sorry, retrying errors gracefully or something. Let's say an error occurs, you guys say you retry it gracefully.
Retry logic.
Yeah.
Implement retry logic.
But you mentioned that it's the same code that runs over and over until it reaches a terminal end.
Yes.
If you say you retry something gracefully, why are you running
I
the
don't
same
say
code?
retry because I said implement retry logic. Meaning that if there's an error in your application,
Okay.
that application should try it until it reaches a certain state, maybe like 2 or 3 times. It completes the circuit breaker, then it handles the error gracefully, that is, it stops it.
Okay.
Without breaking the rest of the application.
Yes, so that it will not consume CPU resources unnecessarily.
And that is my next question, last one. How do you waste CPU resources?
Wasting CPU resources are using virtual machines that are not needed at that time. For example, if you have a high traffic and you have a good number of virtual machines that operate in that time, you are managing your CPU resources. But if you have a low traffic, then you still have the same quantity of virtual machines. You are wasting resources unnecessarily. You are consuming more of the CPU, the RAM, the storage, and you are paying for it as well. So you are wasting CPU resources.
Thank you.
Alright, I was getting to that question somewhere. Okay, Divine.
When you're talking about security, you mentioned front-end security and denial of service. What is that denial of service?
All this is under what we call Cloud Armor. So it's something like how would I put it? Security. This is something like when operations, like people want to hack into your Google Cloud project, like they want to hack into your web application. So that Cloud Armor is already there to be able to deny that service. Like there's something called service account also. You can hack into a Google Cloud application through knowing the service account. So the Cloud Armor is already there to deny that service. So that's what we call denial of service, DOS. Then Google front end is the, I told you that all those are under internet communication layer. So that front end layer, that particular internet communication layer, they have to secure it very well. They can use what we call online sign up. They can use stuff like that. So that's what we call Google front end security.
Okay, so let me correct something about the last response. Most of it was another. Just want to outline that part about denial of service. So it's technically not denying service of the service account. It's actually a kind of attack where they overload your servers with requests so that the servers are so busy handling the fake requests from robots, from bots, that they do not have any resources left to serve actual users. So you may try to open that website and it's under attack and it's just loading, and you never really get the web page back. So in that case, you as a user have been denied service by that application based on the application is busy answering bots. Right? So it's a case of, if I am a competitor, we have similar websites. I can use such an attack to bring down your service, make your service seem unreliable, so that users and customers then come over to use my service. Right? So think of, say, when you're trying to transfer money, right? And you are trying to transfer, it's not working, you're trying, it's not working. But you know this other bank that anytime you transfer it, the alert comes immediately. Where would you put your money? It becomes a no-brainer. So it can be used to create competitive advantage among competitors, and there are people who specialize in this kind of attack and offer it as a service to companies who want to use it to discredit their competitors. Right? So that's basically the idea behind the denial of service. Alright, thank you very much, Benjamin. Wonderful presentation. Again, you did a very wonderful job. Thank you very much.